Hi there, my name is Alan Hung, Strategic Marketing Manager at Terasic Technologies. Today, I will be showing you how Terasic's control panel software can help you verify your hardware to enable a smooth design process. Most engineers have a multitude of problems to face when dealing with new designs, and the last thing they should have to worry about is whether their hardware is operating correctly or not. That's why Terasic has provided the control panel software, a standard tool used in all of Terasic's boards to enable easy debugging and testing of all onboard components. This makes sure that all you need to focus on is your design process. Here I have Terasic's high-speed DE4 board. All that is needed is to attach your board to your PC via the supplied USB cable, and you're ready to begin. I will be testing all the various components and I/Os, including LEDs, 7-seg displays, buttons and switches, memory, USB, SD card socket, temperature sensor, power, phase lock loops, fan control, HSMC connector, and SATA devices. So now my DE4 is on, and I will go to the DE4 control and click on it. Here we're connected to the board, and as we can see, all of the LEDs are lit. And I can control it by clicking on the LED icons. And as you can see, the hardware corresponds to the software. Next, we'll test our 7-segment displays. Here we have 8, all of them are lit. So if we were to say, for instance, change it to 6, 4, you can see that it changes in real time along with the software, with the control panel. So next we'll test our buttons and switches inputs. This is a real-time monitor system where it monitors the slide switches and the buttons and the dip switches. For now, we'll test the slide switches and the buttons. So as you can see, in real time, as I switch the switches on, the control panel corresponds. And the push buttons as well. As I click on the push buttons, the software reacts accordingly. So now we'll go to the memory tab. Over here we have a list of memories from SSRAM to EEPROM, DDR2, SODIMM 1 and 2, and flash memory. We'll test out our SSRAM, and we'll start out with the random access. So first, we will write a hex data to our address 0. So we will write FFFF to address 0. And next we'll write AAAA to address 1. So if we go back to address 0 and we read, we can see that it's FFFF. And at address 1 should be AAAA. And next, we will test our sequential write with our DDR2 SODIMM memory. So what we're going to do first is to disconnect the control panel and then turn off our DE4 board. Now I will connect a 1 GHz memory to our SODIMM 1 socket. Turn the back on and connect again. Once we're connected, we'll go back to the memory tab And here what we'll do is we'll write an Altera file to the memory that we have. And as you can see, it's an Altera logo picture. So over here we'll write file to memory, Altera. And as you can see over here, our length is 3D6E. And if we also specify this from sequential read, we should be able to get the exact same picture. So I'll load, and I'll save it to altera2.jpg. And over here we have Altera 2. We should be able to get the same row. And we have successfully read the data from our SODIMM memory. Next we'll test the USB. This is a very simple identification system with 3 ports. First we'll test out a mass storage device, where we have a USB mass storage device connected into port 2. And here it identifies the mass storage device as high-speed USB storage. Next, we'll test a USB mouse. And once we connect it onto the USB, we can see that it's a full-speed USB mouse at host port 2. Next, we'll test the SD card. This also is a very simple identification system where we can identify the card from the manufacturer's specific data as well as the file system. So I'll insert the SD card right now into the port and click on read. So here we have manufacturer ID, OEM application, so on and so forth. Now, clicking on the temperature tab, a temperature monitor is used to check the onboard temperatures. We can control the temperature sensor to send an alert to our control panel whenever the FPGA reaches critical temperatures. So here we can see that the board temperature is at 31 degrees Celsius and our FPGA temperature is at 41 degrees Celsius. If we were to say, right, temperature max is at 30 degrees and negative 10 degrees, we will then see that we have over temperature on our FPGA. And it lets you set limits on your operational temperature. Next we'll click on the power tab. Over here, the power function is designed to monitor the power consumption of various blocks on the DE4 board in real time. We're able to sense the onboard voltage and current for transceiver power, status 4 power, and the input and output power via our current and wattage. Next, we'll click on the PLL tab. Here we can get our PLLs, and they're currently set at 150, 100, and 100. We can set at a range from 62.5 up to 625. We can disable it, or we can leave it unchanged. Now as we set it, it will configure PLL and we can get the same values back. Now going to the fan tab, we can see that we can control the speed of the fan. Since the Stratix 4 is a high-speed device, we can ensure that it is running optimally by using a fan. We'll control the fan speed by first turning it off. Then we can go to the low speed, middle speed, and next we'll test our HSMC. And the way we test our HSMC is by first using a loopback device to make sure that it is working. So first we'll turn off our DE4 board. Then we'll connect our HSMC device to our port A. After it's connected, we'll turn the board back on. Click on Connect again. Now it's connected, we'll go back to our HSMC and click on Verify. And we can see that it's passed. And since we don't have a loopback device connected to HSMC port B, we can verify that one. And it should be failed. Lastly, we'll test our SATA devices. First, we'll disconnect our board, then we'll turn it off, and connect our SATA devices, our hosts, to our slaves. Now that the cords are all connected, we'll turn the board back on and we'll connect. We'll go to our SATA tab and we'll verify. And we can see that the verification has passed. Now that you have seen how easy it is to debug and verify components and I/Os with Terasic's control panel software, you'll be able to use it in the future with your designs. Thank you for watching.